Spatial analysis is how we apply the science of where to ask questions, solve problems, and make smart decisions. This morning, I want to share with you what's possible when we integrate science into planning and design to tackle the practical problems we face, taking advantage of the hundreds of spatial analysis tools at our fingertips. The city of Boston, for example, has a bustling bike share system that they plan to expand by over 50% in just 2 years. This means two things: extending the existing bike lane network and putting new stations throughout the city. I'll use spatial analysis to tackle both. Now, to figure out where to put new bike lanes, the first thing that we have to do is understand how people are using the system. We can see the highest usage in downtown Boston and near both Harvard and MIT in Cambridge. But this is really just part of the story. Where do people go after they pick up a bike? How are these stations connected? By looking at where each of the trips starts and ends, we can start to get a sense of which stations have the strongest connections. And we can combine our understanding of how people are using the system with powerful network analysis to identify highly used, highly connected stations that lack adequate bike lane coverage. This route between Porter Square and 1 Kendall Square is a great example of an indirect route between two busy stations that could be improved with a new bike lane. So what's the best path for a new bike lane between these two stations? It may seem like a simple routing problem, but a good bike lane is about a lot more than just the shortest path. A good bike lane isn't too steep, so we'll include slope. It's well lit, so we'll include streetlights. It's green, so we'll include trees. And it avoids major roads if possible, so we'll include traffic volume. And we can use spatial analysis to combine our sophisticated weighted overlay with our network analysis to choose the best path. Now, at this point, we've worked on where to put new bike lanes. Next, we want to figure out where to put new stations throughout the city. One of Boston's priorities for locating new stations is providing equitable access, ensuring that everyone is within a 10-minute walk of a bike share. Looking at these 10-minute walk times, we can see that there are some gaps in coverage, which is where we'll put our candidate stations. Now, of course, we also have to consider where people live, and we can combine our network analysis with our population data to calculate which of the potential stations has the ability to improve access the most. And we can see how the model has allocated the underlying population to each of those stations. Now, we've chosen these station locations based on providing access to as many people as possible. But how many people are actually going to use these stations? How many bikes should each of them have? This geostatistical surface models what we know about existing stations to predict usage at each of our new stations. These predictions are important information for planning a build-out. Ultimately, it's about getting creative and integrating and applying the science of where, including powerful network and raster and geostatistical methods to unlock the full potential of our data. It's how you, GIS professionals, build the maps that run the world and shape the future.